Okay, let's look at these problems here. So we're going to use the p-value to decide whether to reject h0 when the level of significance is given. All right, so 0.01. So what we'd be doing again, they told us p is 0.0747. Compare that to 0.01. 0.0747 is bigger than 0.01, so we would fail to reject because the p-value is greater than alpha. All right, now if we did 0.05, 0.0747 is still greater than 0.05, so I fail to reject for that reason. Fail to reject because the p-value is greater than alpha. 0.0747 now is less than 0.10. So now that p is less than alpha, I would reject. So I would reject because the p is less than alpha. Okay. Find the p-value for a left-tailed hypothesis test with a test statistic z equals negative 1.43. Decide whether to reject or fail to reject. Okay, so left-tailed over here, they're telling me negative 1.43. I would have to go and find this area. All right, in order to do that, I would go and use the equals norm dot s dot dist negative 1.43 true, and I'm going to tell you if you do that you end up getting 0.0764. So that's the p-value. Okay, now what did I find? I found that p-value 0.0764 compared to 0.10. All right, it is definitely less than, or indeed less than or equal to 0.10, so I would reject h0 since the p was less than or equal to alpha. All right, do this again. A right-tailed test statistic with z equals 1.15 and alpha of 0.02. Okay, so now this time we're on the right tail and z is 1.15. So again, remember to do this, as with any right tail, we're going to have to figure that area by finding what that left region is and subtracting. Okay, so 1.15. All right, so if I did this as equal norm dot s dot dist 1.15 comma true, so that's the area to the left. I want to do equals 1 minus that, and that's going to give me my area to the right of 0.1251. 0.1251. That's my p-value. All right. And how does 0.1251 compare to 0.02? Well, it's greater than that. So since our p is greater than alpha, we fail to reject h0. How about a two-tailed? Okay. With z of negative 2.05, and then it must be 2.05 for a two-tailed. Okay, so what we're going to do now is we're going to figure out this area here, and then we're going to have to double it, of course. Negative 2.05. So equals norm dot s dot dist negative 2.05 true. Whoops. to 0.05, true. I get 0.0202. So this is 0.0202. Total area is 2 times 0.0202, or in other words, 0.0404. So that's my p-value. Compare my p-value, 0404 to 0.03. It is indeed greater than 0.03. My p is bigger than alpha. I fail to reject H0. Okay, skipping 5 and 6 there. Let's go to 7. All right, let's do the whole thing now based on this information. All right, they've given us the claim mu equals 40. They've given us alpha, sigma, x bar, and n. All right, null and alternative hypotheses. Okay, well, can we do this? Well, they're telling us we can do this, so we have to assume that we can. Again, the sample is bigger than 30, so we're okay. We're assuming this is random, and they've given us sigma, so we are in line for the z-test here. Okay, so H0, H sub A. All right, so they've told me the claim is mu equals 40. Since it's mu equals 40, it has the equals, that has to be H0. And that's the claim they've told me. So the alternative would be not equals 40. This is obviously going to be a two-tail, like this. Okay, so it's going to look like this, but I'm going to need the standardized test statistic z in order to figure it out. All right, so z is x bar minus mu over sigma over the square root of n, or 39.5, as they've given me for x bar, minus 40, which was mu given, over sigma 3.63 given, over the square root of 51, which was given. Crank that out, and you get about negative 0.98. That means that this z is negative 0.98. This one is 0.98, but I'll just go and find this area here and double it. Okay, so if you put that in to Excel, I'm going to skip some steps here, you're going to find that you get 0.1635, which we're then going to have to double. So the total area would then be double that. In other words, 0.3270. So that is our p-value, 0.3270. We want to compare that to the alpha of 0.06. Well, that's definitely bigger than 0.06. So our p being bigger than alpha means we fail to reject H0. And I can already tell you that before I look at the decision and the interpretation, because I failed to reject H0 here. And what were we doing? So the claim was was H0. That's a rejection mode. So I failed to reject it. So as far as the rejection mode is concerned, I did not have enough evidence to reject the claim. So let me see. I failed to reject H0. At the 6% significance, there is not enough evidence to reject the claim.